Hello, let's review your MT1 LT6 affirmation. You had a question very similar to this in the seminar about distance, rate, and time. It says a motorboat takes 5 hours to travel 100 kilometers upstream. The return trip took 2 hours less going downstream. What's the rate of the boat in still water and what's the rate of the current? And they told you can use your calculator. So here's what we're going to do. First off, we have to remember distance equals rate times time. So I want to make a table. In that table, I'm going to put 2 rows in my table. This just helps me organize my data. So I'm going to put my rate, my time, and my distance. And I know distance equals rate times time. So when we go upstream, what's going on? Well, that's going to be the rate of the stream, but we're going against the current, so I'm going to subtract the speed of the current. And it tells us it took us 5 hours to go 100 kilometers. Now going downstream, I'm going to add the current onto my speed. And it took 2 hours going downstream, and that same distance is 100, isn't it? So now we can use our formula. Distance equals rate times time. 100 equals 5 times r minus c. And 100 equals 2 times r plus c. I think I'll rewrite those without the parentheses. We'll distribute, so we get 100 equals 5r minus 5c. 100 equals 2r plus 2c. I think I'm going to use elimination to solve this. I notice that I've got negative 5c and positive 2c. So what's the least common multiple of 5 and 2? Well, it's 10. So what happens, I'm going to take my first equation. In order to make the c 10, I'm going to multiply by 2, so then I'll get negative 10c. I'm going to take my second equation, I'll multiply that by 5. So my new equations are 200 equals 10r minus 10c, or 500 equals 10r plus 10c. Now if I add those together, we get 700 equals 20r. Notice my c's. The reason I did that, the c's, negative 10c plus positive 10c, they cancel. So I'll divide each side by 20. So r then is 35, isn't it? Because the zeros cancel, 2 goes into 70 35 times. Now I have to go back and I have to find c, because the rate is the speed of the boat is my rate. So this would be going in still water. The speed is 35 kilometers per hour. Speed of the river. Of boat, I'm sorry, the speed of the boat. Now I have to go back. I'm going to use my second equation because that looks like I'm working with smaller numbers. We have 100 equals 2r plus 2c. Well, we know r now is 35, so 100 equals 2 times 35 plus 2c. So 100 equals 70 plus 2c. Minus 70 from both sides, and we get 30 equals 2c divided by 2. C is 15 kilometers per hour. So the current is 15 kilometers per hour. Now, we could have done this problem using Desmos, because I said you can use your Alex graphing calculator, but which means you can use Desmos. I am going to take my two equations right here, and I'm just going to graph those. So 100 equals 5r minus 5c. So we go 100 equals, now we can't use c, we have to use x and y. So 5x minus 5y. And then 100 equals 2x plus 2y. I'm going to go back here and make sure my brain remembered what we wrote down. Yeah, 2r plus 2c and 5r minus 5c. Now, I can't see my graphs here because they're too big. But if we click on where they intersect, r is the speed in still waters, so 35 kilometers per hour. Y is your speed of the current, which is 15 kilometers per hour. So you can do it either way. But I would suggest you make a table here with distance, rate, time. Now let's take a look at another one. In this one, I think you just got them mixed up because you have the correct numbers, but you have in the wrong spots. A family has two cars. The first car has a fuel efficiency of 20 miles per gallon of gas, and the second has a fuel efficiency of 30 miles per gallon of gas. During one particular week, the two cars went a total of 1,600 miles for total gas consumption of 65 gallons. How many gallons were consumed by the two cars that week? So I'm going to write this down before I forget. I'm going to let X be the gas used by the first car. I'll let Y be the gas used by the second car. Now, one of our equations is going to be with gas. And we know we used a total of 65 gallons. So I'm going to say X plus Y equals 65. Now, the other car, now let's do one for the distance. The first car goes 20 miles for every gallon. So I take 20 times X. The second car gets 30 miles for every gallon, so 30 times Y. And that total distance is going to be 1,600. Now, if I look at these two, I've got a system of equations here again. Maybe I'll write it below. X plus Y equals 65. Let's get rid of the x's. So what I'm going to do is I'm going to multiply the second equation by negative 20. Because the first equation is going to stay the same. In fact, I think I'll rewrite the first equation first. So I'll say 20x plus 30y equals 1,600. Now if I multiply by negative 20, we get negative 20x minus 20y equals 65 times 20, which would be negative, what would that be, 1,300? Let's double check. 60, yeah, 6 times 2 is 12, 5 times 2 is 10, so yeah, 130. Now let's add them up. Notice the reason we did this, the x's cancel. 30y minus 20y is 10y. 1,600 minus 1,300, well, that's 300, isn't it? Divide by 10. Y is 30. Now we know x plus y equals 65, so x plus 30 equals 65. Minus 30 from both sides. x equals 35. So it should have been 35 for the first car and 30 for the second. I think you had those backwards when you typed them in. You typed in 30 and 35. Once again, could I have done this with my graphing calculator? Sure, we could have. I would have graphed x plus y equals 65 and 20x plus 30y equals 1600. So let's go ahead and do that. So we go x plus y equals 65. And then the other one was 20x plus 30y equals 1600. And then I shrink my graph in so I can see where they cross. They cross at 35 and 30. 35 for the first car, 30 for the second car. So you could have done this either way on these problems. So I've reopened this quiz for you. Click on the redo. Send me your work when you're done, because you definitely have work on these two questions that you should have. And then hopefully after that you should be able to do the test.